Like many other scientists, writers, and dreamers, Elon Musk dreams of flying to Mars and then colonizing it. He plans to begin implementing this plan in the coming years. But can we do it? Or it's a big mistake for all mankind? After all, Mars is a cold planet with low gravity, solar radiation, with conditions on the surface of the planet that in no way can support life. How can we overcome these challenges? And what exactly are challenges we will face? Mars's atmosphere is too rarefied, and more than 95% consists of carbon dioxide, while the oxygen and water content is a fraction of a percent. Therefore, the planet is completely uninhabitable at this point. For example, everyone knows that water is the basis of life. So, if you pour a simple glass of water on Mars right now, one half of the water will simply evaporate, while the other half will freeze. So, how do we create the conditions to maintain liquidity on the red planet? We have to make the atmosphere thicker and denser. This will keep the liquids in optimal shape and increase the average temperature on the planet. Martian polar caps are known to contain some amount of carbon dioxide. Carbon dioxide is even found in regolith, the soil of Mars. Its sublimation would help raise the temperature of the planet and make the atmosphere denser. This would bring the surface pressure closer to Earth's. But the astronauts would still have to use protective masks to breathe. Also, some astrophysicists suggest even more incredible ideas. They propose that several ammonia-rich planetoids or asteroids would collapse on Mars. The impact would produce a huge amount of energy, which would be converted into a heat source. And the gas released would replenish the atmosphere with nitrogen, which is 78% of the mixture we breathe. As you know, the average temperature on Mars during the day is 20 degrees. Isn't that attractive? But that's only during the day. At night, the temperature can drop to -73 degrees. And in winter, the temperature can drop to -125 degrees. To heat the red planet, in addition to the voiced, are also proposed very original options. For example, the use of solar sail and mirrors. They are planned to be placed in the orbit of Mars in order to increase the temperature of the planet's surface. In this way, it is possible and sufficient to heat the planet and release the carbon dioxide. Consequently, after a while, with a denser atmosphere, higher pressure, and acceptable temperature, some plant species could survive on Mars. The biosphere, releasing oxygen and absorbing carbon dioxide, would gradually turn Mars into a habitable world. Weak gravity is one of the most difficult obstacles to overcome. The gravity of Mars is 38% of Earth's, which will certainly affect future colonists, and will not help even the artificially generated atmosphere to stay near the planet for a long time. To resist evaporation of atmospheric layers, scientists propose to build plants on Mars for the production of super greenhouse gases. These substances would not destroy the planet's thinnest ozone layer and would not pose any threat to astronauts on the red planet. But over time, the accumulation of gases would help to thicken the atmosphere and warm the climate. The plants would then complete the terraforming process and turn Mars into a blooming garden in thousands of years. As for the health of the colonists, too weak gravity could cause a kind of weightlessness effect, and over time, the muscles of the astronauts could simply atrophy. And it's still unknown how low gravity could affect newborns. Some scientists even believe that after centuries of life on Mars, humans may evolve, and in this way, a new species of human will emerge. Also, we can't forget the most important problem: radiation. Despite the fact that the planet is much farther from the Sun than the Earth. Again, the fault is the negligible atmosphere and the lack of a magnetosphere, which doesn't allow to shield the cosmic body from the cruel radiation. Scientists have found that in addition to disease, radiation shortens average life expectancy by about 3 years at an acceptable dose of 1000 millisieverts. Therefore, just one flight to Mars could cost the crew at least several years of life. Severe charged particles of galactic radiation can damage the central nervous system. The astronaut may have impaired memory, coordination. He will perform operator functions poorly. While on Earth, a person is exposed to less than 1 millisievert per year. On Mars, this figure is more than 250 millisieverts. It's long been argued that astronauts could use natural geological structures, such as caves or lava tubes, as radiation shelters on Mars. But worst of all, radiation is also capable of penetrating the shelters. High-energy radiation can even penetrate through rock, ionizing and destroying all organic molecules in its zone of effect. Scientists found that the radiation dose peaked at about 30 centimeters from the surface and concluded that to protect the home of the astronauts would need a shield of regolith 10–15 meters thick. So maybe such a shield will serve as a rescue for the colonists at first. But despite this option of protection from radiation, humanity doesn't have at its disposal the necessary technology yet to fully resist radiation. So it remains to hope that we will come to this in time. And even if we can find ways to solve all these problems, we shouldn't immediately prepare the first colonists, refuel rockets, create all the necessary equipment and fly to Mars. No. First of all, we must take care of our home planet, Earth. After all, for many decades, we have poisoned our planet enough, deforested, killed animals. There's still the problem of world hunger and poverty. The world powers are still solving their problems through war. And if we don't want to bring all this and many other problems to Mars, we have to deal with it here. And maybe Earth will flourish again, and we won't need to fly to some other planets and try to settle down there.